Hi guys, very good morning everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, that is the BYJU'S Exam Prep. Very good afternoon or good morning rather everyone. Very good morning everybody. Keep joining the class, and this is the next session on the engineering mathematics. Yes, the GATE 2023 engineering mathematics. Just a moment. Okay. Come on everybody, let everyone join quickly and let's begin up the session. Voice, let us check. Hello. Voice. No, it's good guys, it's good. No, I don't see any big issue with the voice here. Chalo, so let's get moving ahead. Let's get started actually with the session. The differential equations to be covered up in one shot, because that's what I thought. A very less amount of time is left for the GATE examination. Okay, and what are the important things? Because one question is expected from this chapter, that is a differential equation. What are the important things and areas to cover, especially in the last 2 months, so that you score that question from differential equation coming up. Very good morning everyone. I hope you all enjoyed. If you were live yesterday, I hope you enjoyed the midnight session. Okay, the midnight marathon session, isn't it guys? The midnight marathon. It was not actually a marathon, it was this time 20 questions marathon, but more or less in the form of a Menti war, a live quiz. Okay, and many of you are actively participating in the quiz, giving the answers very quickly with accuracy. Okay, let's get started guys. In case somebody new to my classes, this is a brief intro about me. This is your mentor and educator Rakesh, and I have secured all India rank 9 in the GATE examination and completed my masters from Indian Institute of Science, Bengaluru. Right, these are my major area of expertise that I've been dealing for more than 12 years now. Right. So guys, let's get started. Differential equations. So let me first of all brief you what are the important areas. But I see, is it Sunday morning, dull morning, lazy morning? I see quite, I'm not happy with the attendance right now guys. Okay, if you are done, if you are happy with the differentials equation, already you're comfortable, okay, let me know, then we may not conduct the session. Okay, ठीक है Chandrasekhar, sure. Chalo, so differential equations, so broadly how it is classified. If I talk about the syllabus coverage, the distribution, first you have the ordinary differential equation and then you have the partial differential equations. Okay, and sometimes questions are also expected from the partial differential equations, especially for the branches of mechanical and civil here, right? If I talk about ordinary differential equations, then if I talk about the ordinary differential equations, let me be clear, this session will focus on ordinary differential equations first, and within the ordinary differential equations there can be questions on first order as well as higher order. Okay, so there are the two categories, first order and the higher order. Both are equally important. Higher order little bit more important, okay, but first order se bhi you keep getting questions, and that too very simple. Now within the first order differential equation, what all do you study? Within the first order, you're going to study the case of variable separable. Simple, but I'll keep tick marking what is important now. Simple but yet expected. This is one of the simplest, let me tell you, one of the simplest, but yet a very expected question is there. Okay, next, homogeneous differential equation. Just basically go through it once, enough, not much important. Exact differential equations, again not much important. Okay, exact differential equation and the cases of integrating factor, and the cases of integrating factor associated with it. And the next one, linear differential equations of first order. These are important. Okay, so from the first order, either variable separable or linear differential equations. Okay, you keep getting questions from this with good frequency. Okay, so this is the areas where you're going to focus more. This is the areas where you're going to focus really more. Next, if we talk about higher order ordinary differential equations, okay, going to higher order, what are the different cases you have to study? CF and PI methods. So let me write down a little bit more detail. CF and PI method for linear constant coefficient differential equations. The linear constant coefficient differential equation. Okay. So this again will first start with linear differential equations, but that could be of higher order, but they will have the constant coefficient. This is actually very important case, all the cases of CF and PI. Okay. No problem, Ranjit. That's what, if you have not started, we'll talk about the most important type of questions in this session. Okay. Next, we have method of parameter variation. Not much important. Officially, it's a part of syllabus, but most of the questions based on parameter variation have a lengthy solution. That is why for GATE, they don't find much importance here. Euler-Cauchy differential equation is important. Euler-Cauchy differential equation. It is a type of equation, higher order differential equation, which is convertible to linear constant coefficient differential equation. It is although not linear, but it is convertible to linear constant coefficient differential equation and Legendre's differential equation. Okay, these are the important cases that you have to focus in the higher order differential equations. Okay. So what we'll do is, let's get started first of all with the first order, then we move towards the higher order. Okay, and I again repeat, what are the more important things from this differential equation is Euler-Cauchy. Okay, Euler-Cauchy, CF and PI method, this one is very, very important. And if I go back to the previous slide, variable separable and linear differential equations are very much important, right? Okay. Okay, variable separable and linear differential equations. Chalo. So let's move on and let's get started. Let me switch to the PDF actually, and let's get started, guys. Variable separable. Now let us get started with the variable separable quickly. So variable separable will mostly, we'll cover ordinary differential equations first, Sagar, in this particular session. For partial differential equations, I'll plan some separate session in again a concise manner. Okay, in a concise manner, we'll plan partial differential equation also. Uske liye chota sa session hoga, because in concise manner we can do that. The solution of the initial value problem. Now, variable separable, what do you understand by variable separable? That a particular variable can be adjusted with its differential term, can be separated along with its differential term. What you can do simply here is, suppose you have dy by dx is equal to minus 2xy. So you can divide by y on the left hand side. Okay, so dy with y is equal to minus 2x with dx. So shift the dx on the right hand side. This is how the variables are separated, and the next step is just integrating it. The next step is just integrating it. So dy upon y is ln y. 1 upon y integral is log y. Okay, these questions will mostly involve integration process. These are just mostly going to involve the integration process, correct? Okay, and this is equal to minus of x square minus of x square plus c. Ln y is equal to minus of x square plus c. Integral of 2x is x square. Now, there may or may not be some initial value given. Okay, if there is an initial value given, you can find the value of that constant. Otherwise, the options will be in the form of the constant c. Right. So now, they have given y of 0 is equal to 2. That means whenever x is equal to 0, y will be 2. Whenever x is equal to 0, y is a function of x. So if x is 0, y will be 2. From here, you have got c is equal to log 2, right? C is equal to log 2, right? That means now I'll put down the value of c. Log y is equal to minus x square plus log 2, right? So log y minus log 2 is minus x square, or I can say that log of a minus log of b is log of a by b. So log of y by 2 is minus x square. To eliminate the log, you will take the exponent. So you will get the answer here finally, y by 2. So shift 2 on the right hand side. So y will be twice of exponent of minus x square. Okay. Option number B. Option number B. Simple one. Very, very simple. Option number B. I'm telling you, variable separable is very much expected from first order, but it is the simplest of all. Next question quickly. If dy by dx plus 7x square y is 0 with y0 equal to 3 by 7, then find the value of y1. Then find out the value of the y1. Correct? Find out the value of the y1. Chalo, quickly. So what is dy by dx here? Dy by dx here is minus 7x square y. So when you divide by y, dy upon y is minus of 7x square dx. Once again, you integrate ln y is equal to minus of 7 x square integral is x cube by 3 plus constant of integration, and once again they have given the initial value y0 is equal to 3 by 7. y0 is equal to the 3 by 7, sir, right? So if y0 is equal to 3 by 7, x equal to 0 pe y should be 3 by 7. So ln 3 by 7 is equal to the constant, right? So then I can now write down the answer. Log of y is equal to minus of 7 by 3 x cube plus log of 3 by 7. Okay, now no need to simplify and give me the function of y. What we only need to do is find the value of y1. That means what is the value of y when x will be equal to 1? So log y is equal to minus of 7 by 3 plus ln 3 by 7, right? ln 3 by 7, right? So you can bring the ln on the left hand side. So log y divided by 3 by 7 is minus 7 by 3, right? What will be y? It is equal to 3 by 7 e raised to the power minus 7 by 3. 3 by 7 e raised to the power minus of 7 by 3. It's option number A. Okay? That is the option number A. Okay. 3 by 7 e raised to the power minus 7 by 3. Done. Next question. The general solution of the differential equation. Now I'm taking a GATE question also as a reference. The general solution of the differential equation, to see how simple questions can be there in the exam as well. Okay, so what is this? Dy by dx dl is equal to 1 plus cos 2y. Now 1 plus cos 2 theta is known as 2 cos square theta, divided by 1 minus cos 2 theta is known as 2 sin square theta, and this one becomes cot square theta. Cos by sine is cot square. Okay, right? Or no, sorry, I'm sorry, this one is x. I'm so sorry for this. We can't write it as cot because this is cos square y upon sine square x, two different functions. But what we can do here is variable separable. Yeah, we are solving the variable separable as of now. 2 and 2 cancel. Shift the cos square y with the dy. So dy upon cos square y is equal to the dx is divided by sine square x, right? 1 upon cos is sec. So you have sec square y is equal to 1 upon sine square will be the cosec square dx. And now we are going to integrate on both the sides. Good afternoon, all keep joining. So now we are going to integrate on both the sides, right? Once you integrate sec square theta, integral of sec square theta is tan theta. So tan y, integral of cosec square theta is minus cot theta. So is minus cot y plus c. Okay, minus cot x, sorry, right hand side is x, minus cot x plus c. So tan y plus cot x is equal to c. Your answer should be option number C. Tan y plus cot x should be equal to the c. Tan y plus cot x should be equal to the c, right? Should be equal to the c. Okay, next one. Moving ahead to the next question. Okay, a GATE 2 mark question again to enable you for some practice related to GATE as well. An ordinary differential equation is given below. Okay, sometimes the question can test your little bit integration techniques. Right. Here, dy divided by y is going to be equal to dx divided by x log x. dy upon y is equal to dx divided by x log x. dx divided by the x log x, correct? Right. Now we'll integrate on both the sides, right? But to integrate on both the sides, we have the integral of 1 upon x log x. For that we need to simplify a little bit, and we will just say log x is equal to the t. We will just say the log x is equal to the t. Log x is equal to the t, right? If log x is equal to t, 1 upon x dx, differentiating both the sides will be dt. Okay, so now you can write down, now this becomes simple. Dy upon y is equal to, what is 1 upon x dx? That will be dt. Okay, so this can be simply replaced by the dt divided by log x, and that is equal to t. So dy upon y is equal to dt upon t. Dy upon y is equal to dt upon t, right? Now integrate on both the sides. Dy integral, 1 upon y integral is log y. 1 upon t integral is log t. So log y is equal to log t plus c, right? What do we have? ln y is equal to ln t, right? T will be further equal to log x, usko baad mein dekh lenge. So log y minus log t. So log of y by t is equal to c, right? So what is y by t? It is equal to e raised to the power c, and e power c will be some constant, exponential of constant. Okay, now what is the value of y? That is equal to k into t, and t is equal to log x. So y is equal to k log x. Only one simple integration technique they have tested, and this becomes a 2-mark question. So that's what I wanted to highlight you, and this is just 1 or 2 GATE examples. Regular examples also we have solved, but this is just to show you that these are the level of questions from variable separable, and aate rehte hain. Many years you will find variable separable. Okay, answer is k log x. Okay, answer is k log x. Now there can be differential equations which are reducible with variable separable, reducible to the variable separable form. Reducible to the variable separable form, right? And one such case is dy by dx is equal to any function of ax plus by plus c, right? Ax plus by plus c, that means it should be a linear term, x power 1, y power 1, ax power 1 plus by power 1 plus any constant c. I'll just tell you the method, don't link it to anything else. The method is put down ax plus by plus c is equal to t. Put down ax plus by plus c is equal to t. These are the two things to be taken from this slide, and have a look into the question. Again, as a reference, GATE 2 marks question directly. dy by dx is equal to x plus y minus 1 whole square. X plus y minus 1 whole square. Square. Suppose x square is a function. X square is a function of only x. Here x plus y minus 1 whole square. There is a square of which? There is a function of x plus y minus 1. The function is known as square, but whose function? X plus y minus 1. Or I can say that this is a function of the form ax plus by plus c. The method I have told you. The method I have told you. What is the method, sir? Put down that ax plus by plus c. Put down the ax plus by plus c. What is that here? X plus y minus 1 equal to t, and solve further. You will get the answer automatically. Solve further. X plus y minus 1 is equal to t. Differentiate both sides with x. So 1 plus dy by dx will be dt by dx, right? Why I differentiate with x? Because I need to know what is dy by dx. So from here, what is the dy by dx? And that is equal to the dt by dx minus 1. That is equal to the dt by dx minus 1. dt by dx minus 1. dy by dx is equal to dt by dx minus 1. Got this? Okay, now let's put down the calculations here. So we have dy by dx is equal to x plus y minus 1 whole square. Dy by dx is equal to the dt by dx minus 1, and this is equal to t square. Right, so what is dt by dx, dear? The dt by dx is given by the t square plus 1. Right, divide the t square plus 1. On the left side, dt upon t square plus 1 is equal to the dx. And now I'll just integrate on both the sides. So 1 upon t square plus 1. What is 1 upon t square plus 1 integral? 1 upon x square plus 1, tan inverse x. Tan inverse x is equal to integral dx is x plus some constant. So t is equal to x plus c. What is t? Sorry. T is equal to tangent of x plus c. I have shifted the tan on the right hand side. It is tangent of x plus c. And what is the t? T is x plus y minus 1. So x plus y minus 1 is equal to tan of x plus c. How the options are available? Options are available in terms of y. So y is equal to 1 minus x plus tangent of x plus c. 1 minus x plus tangent of x plus c. Plus tangent of x plus c. 1 minus x plus tangent of x plus c. Right. ठीक है, done. Let's move ahead then to the next case. Okay, let's move ahead to the next case. So guys, if you have understood this, one more similar activity I'll give you as homework. Kindly try this question as homework. Dy by dx is equal to cos of x plus y. Okay, what is this cos of x plus y? This is a function. Cos is a function of what? X plus y, right? And this x plus y is like ax plus by plus c. C0, no problem. So again, you have a function of ax plus by plus c, and you know the method. You have to do just one substitution. X plus y equal to t. After that, what happens? You get the variable separable automatically. After that, you get the variable separable automatically. Okay, dear? Get the variable separable automatically. Okay. Moving ahead to the next case. Moving ahead to the next case. Okay. Right. Let me first come up and take the linear differential equations of first order. I hope you are all aware about what linear differential equations are. If there is any doubt with the category of differential equation, let me know, because I'm focusing more on the methods and problems here. Methods, the important problems here. But in case if you have any doubts regarding what linear differential equation is and all, please let me know. Please let me know. Okay. A differential equation of the form dy by dx plus py is equal to q is the linear differential equation of first order, because there is only the first derivative. Now, order is the highest derivative. So, highest derivative is dy by dx. Okay, that's the first derivative, right? The dependent variable y and its derivative. Okay, both are in first degree. Let me quickly give you the one-line definition of linear differential equation. Dependent variable and all the derivatives, even if it is higher order, all the derivatives must be in the first degree, power 1, and they should not be multiplied together. They should not be multiplied together. So yes, y and dy by dx both are having the power 1. Y power 1, dy by dx power 1, and they are not multiplied together. Hence, it's a linear differential equation of first order. What is the method of solving it? To solve this, we first evaluate its integrating factor. And what is the integrating factor here? It's given by e raised to the power integral p dx. It is given by e raised to the power integral p dx. And then the solution of this differential equation is given by y into integrating factor is equal to integral of q into if dx plus c. The q function multiplied by if, then integrate, and then plus c, right? And then there are some equations which are convertible to this equation. We will talk about that also, right? There are some forms, okay? And then Bernoulli's equation will also come up here. Bernoulli's differential equation bhi yahan pe aa jayega. Let's have understanding with the question straight away. X power 4 dy by dx plus 4x cube y is equal to x power 8. Okay, what should be the value of y? What should be the value of y? X power 4 y dash plus 4x cube y is equal to x power 8. What should be the value of y? What should be the value of y? Okay, the solution. Okay, so this is like x power 4 y dash bole to dy by dx plus 4x cube y is equal to x power 8. So what should be dy by dx form? So dividing by x power 4. Let's start with dy by dx plus something. Okay, so divide by x power 4. So you get x cube by x power 4 will be 1 by x. So 4 by xy, and right hand side it is x power 4. And now you can feel that this is p and this is q. As I told you in the previous statement, dy by dx plus py equal to q, where p and q are functions of x only, or maybe constant, but not function of anything else. So p and q are known as the functions of x, right? So here you have p and q, 4 by x and x power 4. They are the functions of x. What is the first step? Guys, what is the first step of solution? Is integrating factor. Sometimes the question can only be integrating factor of this differential equation. That is e raised to the power integral p dx. E raised to the power integral p dx. So that is e raised to the power integral 4 by x dx. Okay, 1 upon x dx. 4 तो constant है. 1 upon x integral is ln x. So e power 4 log x. Yeah, you can write it as a factor outside log will go inside and can become the power. So it is e power log of x power 4. E and log are inverse of each other. They'll cancel and the answer is x raised to the power 4. So if the question is only integrating factor, you can write down the answer as x power 4. But they are asking the solution. Now let us come to the solution. What was the solution formula, everybody? Y into if is equal to integral q into if into dx plus c. Integral q into if dx plus c. Integral q if dx plus c. Correct. Okay, what is the integrating factor here? Is x की power 4 is equal to, one more integration will come. Q was x की power 4. Integrating factor is again x की power 4. Right. So it is total x की power 8, and integral of x की power 8 will be x power 9 divided by 9. X power 9 divided by 9. Okay. So what should be y? Divide by x power 4. So you have x power 5 by 9 plus c is divided by x power 4. X power 5 by 9 plus c divided by x power 4. Option number A match हो रहा है क्या? Perfect. X power 5 by 9 and c by x power 4. Correct. So option number A is the correct match here. Just a second. Yeah, that is the correct match here. Moving ahead to the next question now. Okay. Now a GATE 21 question as a reference, and I'm telling you, many questions you can find in the linear differential equations of the first order. If yx satisfies the differential equation sin x dy by dx plus y cos x is equal to 1, subject to the condition y pi by 2 equal to pi by 2, then what should be the value of y pi by 6? Then what should be the value of y pi by 6? Then what should be the value of y pi by 6? Come on. What should be the value of y pi by 6? Come on, everybody. Okay, first of all, again, like the last question, make it in the form of dy by dx plus something. Right? Write this in the form of dy by dx plus something, and for that you will have to divide by sine. Okay, divide by sine, so cos upon sine will become cot x. So cot xy is equal to 1 upon sine, that will be cosec x. Right, and that is perfect. Dy by dx plus py is equal to the q. Dy by dx plus py equal to the q. That is not an issue. Dy by dx plus py equal to the q. ये form आ गया. Then the first step is to get the solution. We don't want the expression of y, but we need some value of y. For that we have to solve the differential equation. So what is going to be its integrating factor? Again, e raised to the power integral p dx, and that is e raised to the power integral ln sin x. Okay, for positive value of sin x, of course, e and log will cancel, and the answer is just sin x. The integrating factor आ गया sin x. The integrating, because it is the integration of e raised to the power integral cot x dx. That is e raised to the power ln sin x, and the answer of the integrating factor is sin x. Done. Integrating factor आ गया. Now let's start with the solution. The solution part, guys. Y into integrating factor is equal to integration of q. Sir, what is the q function? Is cosec x. The q function is cosec x. Integral q into integrating factor again dx plus constant of integration. Okay, so y sin x is equal to cosec and sine are inverse of each other, they cancel, so you are left with integral dx only. So this is actually integral dx plus c, and integral dx is equal to x then plus c, x plus c. Right. Now given y pi by 2 equal to pi by 2, we don't want the y expression, so let's find the value of the constant first of all. Y pi by 2 is equal to pi by 2. That means when x is pi by 2, y is also pi by 2. Pi by 2 sine of pi by 2 is equal to pi by 2 plus c. Sine pi by 2 is 1, so pi by 2 will get cancelled, and you are getting the value of c equal to 0 here, right? And if c is 0, that means y sin x is equal to x. We need the value of y pi by 6. Okay, so यहाँ पे हम रख देंगे y pi by 6. So y sin pi by 6. When x is pi by 6, what should be the y? Sin pi by 6, like sin 30 degree, and sin 30 degree is known as half. Sin 30 degree is half. So y into half is pi by 6. Y should be 2 से 2 cancel hoga. Y should be the pi by 3. Y should be the pi by 3, dear. Y should be the pi by 3. MCQ question, 2 marks, simple one, option number C. It's the option number C, dear. Correct? The correct answer here is option number C. That is pi by 3. That is a pi by 3. चलो चलते हैं फिर अगले क्वेश्चन की तरफ. What is the next question here, sir? Let y dash x plus yx into g dash x is equal to gx g dash x for y0 equal to 0, where f dash means the df by dx, of course we know, and gx is the given non-zero constant differentiable function on R with g0 equal to g2 is equal to 0. What should be the value of y2? Good one question. Okay, but eventually it is going to involve the same process, because if I write down this equation, देखो y dash means dy by dx, right, plus g dash into y is equal to g into g dash. Everything is a function of x, we know. Okay, so I'm just eliminating that bracket. Now what is this? This becomes the p. It's a function of x, g dash x, and this becomes the q. dy by dx plus py equal to q. So it's your regular form. It's your regular form. dy by dx plus py equal to q. But when you are going to do the integral of p dx, na, p itself is g dash x. Okay, integral and differential will cancel each other, right? And you will get the function g. G is first differentiated and then integrated, so you will get back the value of gx. So integrating factor for the problem is gx. Integrating factor is gx. Okay, sorry, not the integrating factor, I mean integrating factor will be e raised to the power integral p of dx. Okay, and that will be e raised to the power integral p dx is gx. So integrating factor is e power gx, dear. Okay, the integrating factor is e raised to the power gx. E raised to the power gx. That is done. Now the solution part. So y into the integrating factor. Integrating factor is e की power g is equal to integration of q. Where what is the q? G into g dash. Integration of q into integrating factor dx plus constant. Now little bit techniques of integration has to be involved here. Little bit integration techniques has to be involved there. So what you are going to do here? What you are going to do here is we can have a substitution. Say e raised to the power g is equal to some function t. E raised to the power g is equal to t. So when you differentiate on both the sides, e power g, okay, g matlab gx, it's a function. E power gx, that is the integrating factor, isko t bol denge. Okay, so differentiate e power gx is e power gx. By the chain rule, g dash x will come. So e power gx into g dash x dx should be equal to the dt. Should be equal to dt, right? So g e power g into g dash into dx, this will be the dt. What will be left is the gx. So what will be the gx? E power gx is t, so gx will be equal to the log t, right? So then this integration is going to become g function is log t, and this whole part becomes the dt. G dash e power g dx, this is the dt, right? What is the integral of log t? Integral of log x is x log x minus x. So here it will be x log x minus x, or t log t minus t. T log t minus t. Later on we can substitute t. Okay. ये यहाँ पे कर ही देते हैं. What is the t? T is equal to e power gx. Log t is just gx minus e power gx. So what is the solution for this? Now what is the solution? What is the solution here? Y into e power g is equal to integral, which is solved as e power g into g minus e power g plus constant. Now they have given y0 equal to 0, y0 equal to 0, okay, and g0 equal to g2 equal to 0. देखो अब क्या क्या जरूरत होगा. y0 is 0. Now let's come to the initial value problem. y0 is 0, right? y0 is equal to 0. That means when x is equal to 0, y will be 0. at x equal to 0. But if x is equal to 0, what is G0? If x is equal to 0, what will be the value of G0? That is also given to you as 0. That is also given to you as 0. तो ये सब कुछ जब रख देंगे ना, then you will get y be 0. Okay. Then e raised to the power g will be 0, is equal to e power g into g minus e power g plus c. This is 0, but this will be 1. तो solve होके c का value 1 आ गया. Solving, you get the value of c equal to 1. Okay. Now I need the value of y2. Now I need the value of y2. Right. y2 के लिए y into e raised to the power g of 2 is equal to e raised to the power g of 2 into g of 2. ये पूरा gx function है, minus e raised to the power g of 2 plus constant, and constant is 1, and that is why they have given the value of g2 also. Sir, what is the value of g2? That is also 0. That is also 0, right? So y into e power 0 is equal to e power 0 into 0 minus e power 0 and plus 1. E power 0 is 1, the right hand side is entirely 1. Okay, so your answer for y is also 0. So the value of y2 should be the 0, dear. The value of y2 is going to be 0. NAT type question, I will just write down the answer here, that is 0. The answer is just equal to the 0. Everybody correct? The answer is just equal to the 0. Chalo. Next one. Now there will be equations reducible to the linear differential equations of first order, and one such category is f dash y dy by dx plus fy into p is equal to q. That means, right, normally we have py, na? Normally dy by dx plus py equal to q. But if you have p into some function of y, but the derivative of the function appears with dy by dx, then it will be an equation reducible to linear differential equation. Okay, then how do you convert to linear differential equation? You have to put down the fy equal to u. Put down whatever is the function of y equal to u and then solve. Then we'll solve in the questions. We don't want to memorize the formula. This is just the method I'll give you. So let's understand here. Solve the differential equation. Solve the differential equation. Tan y dy by dx plus tan x is equal to cos y cos square x is equal to, see, what is there on the right hand side is strictly q. Q means function of x. P and q are same. P and q should be the functions of x. P and q should be the functions of x. P and q should be known as the functions of x, correct? Should be known as the function of x. Okay. So first of all, what I will do is I want to eliminate by cos y on the right hand side. Okay, so divide by the cos y. Okay, so you have tan y divided by cos y dy by dx plus tan x divided by cos y is equal to cos square x, is equal to the cos square x, correct? Now tan upon cos. Okay, now we have tan divided by cos. What should be tan divided by cos? Actually tan is sine upon cos, the sine upon cos square, right? This will become sine divided by cos square, and 1 upon cos square is sec square, right? So it is actually in the form of sine y is multiplied by sec square y dy by dx plus tan x upon cos y. 1 upon cos is again sec. So here there is some mismatch, that is cos y and that is cos square x. Cos y se divide kiya. This is perfect. Yeah, let me write it as tan y only. Forget. I will write it in the form of tan y only. Tan y divided by cos, and 1 upon cos is sec. Tan y sec y dy by dx plus tan x upon cos y. Right. 1 upon cos is again will be written as sec. Right. Sec y into tan x. Yeah, इसको reverse लिखते हैं. Plus tan x into sec y is equal to cos square x. This goes good. This goes. Okay. Now, hi, good afternoon. Now you can feel that this can be represented as q and this can be represented as p. P and q are the functions of x. But normally we have p into y. What do we have normally? We have p into y. But what is this? What is this? P into function of y. Right. What is this? This is a function of y. I told you the form ki when p is not multiplied by y, but p is multiplied by function of y, then what to do? If p is multiplied by function of y and you get the derivative also available with dy by dx, if f dash y is also available, then this method is applicable. So dekho, what is the differentiation of sec y? Differentiation of sec theta is sec theta tan theta. Is sec theta tan theta. So that is why this automatically becomes the derivative of y. And then you have the form f dash y dy by dx plus p into fy is equal to q. And how to solve it? I told you how to solve it. Put the function of y is equal to some variable, that is u. Put the function of y is equal to some variable and that is equal to the u. Put fy is equal to u. Correct? Put down the fy is equal to u. Put down fy is equal to u. Right? So put karenge, what is fy? Sec y. Put down the sec y is equal to u. So what is the derivative of this? Sec y tan y dy by dx. Differentiating with x both the side. That is why dy by dx will also come is du by dx. Right? So that is why this whole term, this whole term will become du by dx. This whole term will become du by dx. So you have du by dx, right? Plus p into fy, where fy now u is equal to q. Now this is linear differential equation of first order or not? Tell me. Now that is linear differential equation of first order, correct? Now this is linear differential equation of first order. Only thing is y ki jagah u hai. You don't have the y, you have the u. It is just equal to u. Chalo. So let's work out now. Let's work out the integrating factor. The first step we know is the integrating factor, that is e raised to the power integral p dx. E raised to the power integral p dx. And what is the p? It is tan x. Right? Integral tan x dx. What is the integral tan x? E raised to the power log of sec x. Okay, integral of tan x is log of sec x, and then the answer is only sec x. E and log will cancel. This is sec x, correct? This is the sec x. Chalo. So aagya, what should be the solution now? Let's talk about the solution. Acha dear, what should be the solution here? Y. Y nahi aayega. It's a function of u here. So what should be your solution? Rather than y, you have to put u. U into integrating factor should be equal to q into integrating factor dx plus c. So this is the important point to note, that in solution first you will write down the u. First you are going to write down the u. So what should be the u? What should be the u is sec y multiplied by the integrating factor, that is sec x, is equal to integration of the q. Integration of the q. What is the q here? What is the q? Q cos square x into integrating factor, that is sec x dx plus c. Okay, so cos and sec, they're inverse of each other, they will cancel. Okay, so we have sec y is multiplied by sec x is equal to integral of cos x. Integral of cos x will be sin x. So sec y sec x is equal to sin x plus c. Yeah, sending the sec x on the right hand side. What is sec of y? Only y term on the left hand side. 1 upon sec is cos. So right hand side it becomes the cos. Cos x is whole multiplied by sin x plus c. Sec y is sec y is equal to cos x into sin x plus c. Cos x whole multiplied by sin x plus c. Right? Done? Yes, Payesh, correct. So this is what is the answer. This is what is the final answer, correct? Chalo, done. Okay, moving ahead to the next. This is done. Moving ahead to the next example then. Okay, Bernoulli's equation. Differential equation of the form dy by dx plus py is equal to qy power n. dy by dx plus py is qy power n, where p and q are functions of x, is known as the Bernoulli's equation. dy by dx plus py is equal to q. That is a normal linear differential equation. But when q is multiplied by y power n, then it is the Bernoulli's equation. And the method to solve this is, first of all, I'll just tell you the procedure directly to be applied in the question. Divide by y power n. Once you divide by y power n, so you have 1 upon y power n. Let me write it as y power minus n. Y power minus n dy by dx plus p y ki power 1 minus n is equal to q. Y power minus n dy by dx plus p y ki power 1 minus n is equal to q. Okay, and now you will have the substitution. Put y raised to the power 1 minus n is equal to some variable u. Okay, and then solve. Like fy is equal to u, I'll given you the substitution, and now you have to solve. And let's put it in the question and then solve actually. Let's put this in the question and solve. Okay, so solve dy by dx minus 3y is equal to minus 12y square. Right? Let this be p, let this be q. So this is q y power n. Let this be p, let that be q. P and q are either functions of x or they could be constant, right? That is what I have mentioned. So यहाँ पे what is the method? यहाँ पे what is the method? It's a Bernoulli's equation and you have to divide by what? You have to divide by y square. You have to divide by y square. Okay, so you get 1 upon y square dy by dx is equal to, minus 3 upon y is equal to minus 12. Is equal to minus 12, right? Then you can put down this term 1 upon y. You have to just put down this term. As I told you, y power 1 minus n ko u rakhenge. Y power 1 minus n here is 1 by y, right? So 1 by y is equal to t. Put down the 1 by y is equal to t. Yeah, you can also put down minus 1 by y equal to t. Plus minus is not going to affect much. So if I put minus 1 by y is equal to t, now what is going to happen? What is the differentiation of 1 by y? Minus 1 by y square dy by dx. So minus already hai, so it will be directly 1 upon y square dy by dx. Right hand side dt by dx. So that is what you get, the straightforward substitution of this as well. Okay, so what is your equation now going to be? dt by dx plus 1 upon y minus 1 upon y is t. So this becomes 3t is minus 12, correct? यहाँ लिख देते हैं dt by dx plus 3t is equal to minus 12. dy by dx, only thing is y replaced by t. Y replaced by t, या u, any variable you want to name. Okay, so dt by dx plus pt is equal to q. तो सबसे पहले you will calculate the integrating factor here. Integrating factor is e raised to the power integral p dx. P की जगह 3. Okay, so 3 constant, integral dx is x. So integrating factor is e power 3x. Integrating factor is e power 3x. Then बात करेंगे solution की. What should be the solution? We'll talk about the solution. So what should be the solution here? Quickly everybody. Solution में y नहीं आएगा. सबसे पहले write down t. T into integrating factor is integral q into integrating factor dx plus c. Okay. So what is the integrating factor? E power 3x is equal to integral of q. Q यहाँ पे है -12. Right, into integrating factor e power 3x dx plus c. Okay, solve this up quickly. T की जगह आ जाएगा how much? T was -1 by y. So -1 by y यहाँ लिख लेते हैं. -1 by y e power 3x is equal to -12 e power 3x integral will be e power 3x divided by 3 plus constant. E power 3x if I divide, so minus of 1 by y is equal to minus of 4 plus c e power minus 3x. Solving this completely, y will be 1 upon 4 minus c e raised to the power minus 3x. That should be your answer. 1 upon 4 minus c e power minus 3x. That is the answer for y. However, you can arrange it. That's not a big deal. However you want, you can arrange that. Chalo. If this is sorted, let's go to the next one then. Clear? Let's go to the next one then. Y is 1 upon 4 minus c power minus 3x. Next one is, there's a question in GATE 2 marks. Solve the differential equation, consider the differential equation and tell me the integrating factor only. Tell me the integrating factor only. Dy by dx plus x upon 1 minus x square y is equal to x root y. Dy by dx plus py is equal to q y raised to the power n. Q is multiplied by y power n. Root y is what? Y power half. Root y is simply equal to the y power half. Okay. So this can be written as dy by dx plus x upon 1 minus x square into y is equal to x y raised to the power half. So what you are going to do is divide by y power half. Divide by y power half. Okay. Now, when you divide by y power half, this becomes y power minus half dy by dx plus y upon y power half. Y upon y power half will be y power half is equal to x. P and q are still there. Then you'll have the substitution. Then you will have the substitution. What is the substitution? Put down y power 1 minus n. जो भी बचा है यहाँ पे, तो put down this y power half is equal to t. If y raised to the power half is t, when you differentiate na, y power n का derivative, n y raised to the power n minus 1. Right. So, what is y raised to the power minus half dy by dx will become 2 dt by dx. Will become 2 dt by dx. So, this will be written as 2 dt by dx. So, we have the differential equation 2 dt by dx plus x upon 1 minus x square. X upon 1 minus x square into t is equal to x. Now, only one last step is divide by 2. dt by dx plus 1 by 2 x upon 1 minus x square t is equal to x by 2. Right? This is of the form dt by dx plus pt equal to q. dt by dx plus pt is equal to q. Linear differential equation. P and q should be the functions of x. Yes. So p as well as q. This is q and this is p is a function of x. Integrating factor is integral e raised to the power integral p dx. So let me first solve this separately. I have integration of x upon 2 1 minus x square dx. यहाँ पे कुछ नहीं करना है. You have to just put down 1 minus x square equal to t. 1 minus x square is equal to the t. Okay. So this is going to become how much? Okay. If 1 minus x square is equal to t, na, So minus 2x dx is equal to dt. Minus 2x dx is equal to dt. तो x dx कितना हो जाएगा? X dx will be minus dt by 2. Further there is one more, divide by 2 and then t, right? Minus 1 by 4, 1 upon t integral is log t. Okay, 1 upon t integral is log t. So what is the integrating factor then? E raised to the power integral p dx. The answer of integral p dx is minus 1 by 4 log t, or better send the minus 1 by 4 to the log. So that will become the power t power minus 1 by 4. E and log will now cancel and t power minus 1 by 4 is the integrating factor. What is the value of t? T is 1 minus x square. So your integrating factor is 1 minus x square power minus 1 by 4. 1 minus x square power minus 1 by 4. That is the option number D. That is the option number D. 1 minus x square raised to the power minus 1 by 4. ठीक है, done. 1 minus x square power minus 1 by 4. चलो, right, quickly moving ahead to the next then. Okay, so next we'll take up the linear differential equations of constant coefficient. That is what I told you, na, LCCDE. Linear constant coefficient differential equation. This is the next important category. Differential equations which can be of higher order as well. LCCDE of higher order. First order linear to dekh liya. But the only thing is, when we talk about linear differential equations of higher order, we'll be talking about constant coefficients only, right? Constant coefficient only, right? Say for example, better to write down with an example. Suppose you have d2y by dx square plus 3dy by dx plus 2y is some function of x is gx, where gx can be any function of x, right? हाँ बिल्कुल हार्दिक, 100%. Differential equation is there for mechanical. आता है question ना? Okay. Now that is what you see. Constant coefficient, whether you talk about y or dy by dx or d2y by dx square, what are their coefficients? What are their coefficients? This is 2, 3, this is what? This is nothing, matlab 1. Okay. So all of them are having the constant coefficients. All of them are having the constant coefficients. Clear? d2y by dx square plus 3dy by dx plus 2y is equal to gx. So all of them are having the constant coefficients, right? Right hand side can be any function of x, but y and all the derivatives will have the constant coefficient, right? यहाँ पे the method that you are going to apply is d2y by dx square plus 3dy by dx plus 2y is some function of x, and what we are going to do is we are going to put the dy dx is equal to the differential operator that will be named as capital D. Okay, put d by dx as the derivative operator. This is known as the differential operator D. Okay, so second derivative will become d square, right? D square, यहाँ पे वो भी लिख देते हैं, right? So automatically the second derivative means the double differentiation d of d, that is d square. Third derivative अगर कहीं पे आएगा, so that will be d cube and etc, right? So that this equation will become d square of y plus 3 d of y plus 2 of y is equal to the gx, correct? Right, now very clearly I can take the y common. D square plus 3d plus 2, y common is equal to gx. Now whatever after taking y, whatever is left is a function of d, because rest everything is constant. That is why we are taking constant coefficient only. 1, 3, 2, these are constant. Okay, so whatever is inside the bracket, it only depends on d. It's a function of d. This is known as the function of d. The function of d into y is equal to g of x. function of d into y is equal to g of x. That is the final representation we will say. The function of d will depend on the type of differential equation given. Here it is d square plus 3d plus 2. That can change also. So function of d into y is equal to g of x. Okay. Function of d into y is equal to g of x. So let's say that is the general representation coming up here as well. F of d into y is equal to g of x. Now there may be, right? Great Tarun, great to know that. God bless you and hope you perform your best in the coming examination. So suppose if the forcing function on the right hand side is nothing, that is if gx is equal to 0, we also call this equation as linear homogeneous differential equation, and that solution of that will only depend on the CF. Okay, because the complete solution is derived by these two. Okay, that is the CF and PI. Now, this is the very important topics. I told you in the beginning only, LCCD is the most important topic. Okay, so either there can be a question on complementary function or PI, or there can be a question involving both. वो थोड़ा सा rare होता है, but yeah, they can more expected questions on either CF or the PI part. Okay, now let's talk about the methods of both. Okay, let's talk about the method of both. Let's talk about complementary function. Complementary function के लिए the first step is whether the gx is not equal to 0, you have to assume it to be 0. Let the gx is equal to 0 to find the complementary function. To find the complementary function, right? So you have f of d into y is equal to 0, not fd is equal to 0, sorry. F of d into y is equal to 0. F of d into y is equal to 0. Okay. Now, you will make an auxiliary equation. You will make an auxiliary equation. What is the auxiliary equation? Okay, there are some typo errors here, so I am writing it separately. What is the auxiliary equation? Auxiliary equation means, so see, d is the operator. It cannot have a value. What is d? It's the derivative operator, d by dx. For an operator, we can't find a value, right? So let's not solve the equation in terms of d. Let's call some other variable m. Let's call some other variable m, and f of m is equal to 0. F of m is equal to 0. Okay. In the d, replace the d equal to m and call it as f of m equal to 0. So I'm just copying the previous example only. So if I put down m, I get the equation m square plus 3m plus 2 equal to 0. So it's a quadratic equation. If it is a third order equation, you may have a cubic equation. So you have an equation that will give you some roots. Here, what are the roots? -1 and -2. So the CF will only depend on the roots of auxiliary equation. We are just talking about the methods and final to be applied on the problem. That is what you require in the last 2 months. That is the moral of the story. Okay, so that auxiliary equation will have some roots. Here they are -1 and -2. Both these roots here are real. Both these roots are real as well as distinct. Both these roots are real and distinct. Now, based on the type of root obtained, dear, based on the type of root obtained, you will be writing down the complementary function. You will be writing down the complementary function. Let's quickly see all the cases and then let's quickly solve the questions. If all the roots are real and different, like the previous example, if all the roots are real and different, so the complementary function is given by c1 e power m1x plus c2 e power m2x, etc., 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 etc. So for the previous example, when m was -1 and -2, real and distinct, what is the complementary function? c1 e power m1, m1 and m2 are the value of the roots. So c1 e power minus x here plus c2 e raised to the power minus 2x. c1 e की power minus x plus c2 e की power minus 2x. c1 e power minus x plus c2 e power minus 2x. Cool? That is the complementary function. Simple. If the two real roots are equal, suppose m1 and m2 will be equal. Suppose we will take up questions, all relevant questions. Just let's have a look into this. So we have y equal to c1 plus c2x e power m1x. c1 plus c2x is combined e power m1x plus c3 e power m3x. Suppose m3 is a different root and there is m4 also, etc. Suppose if three roots are equal, so c1 plus c2x plus c3x square e power m1x plus c4 e power m1x. Matlab, for example, you were given a case where m is equal to 1, 1 and 3, suppose. Two roots were real and equal, another one was distinct. So what will be this complementary function? I have not given you the differential equation. Directly I am telling you, suppose these were the roots of auxiliary equation. Then two roots are equal. So you will club c1 plus c2x. You have c1 plus c2x e power m1x, whatever is that common root, e power x, plus c3 e power 3x. c3 e power 3x. c3 e power 3x. Cool hai? c1 plus c2x e power x plus c3 e power 3x. This is the auxiliary equation. And this is the complementary function directly. Similarly, if three roots are equal, to c1 plus c2x plus c3x square into e power common root. Okay. Next, if a pair of roots is irrational, alpha plus minus root beta, like 2 plus minus root 3, okay, anything of that form, okay, then the complementary function can be written as e power alpha x, c1 cos hyperbolic root beta x plus c2 sin hyperbolic root beta x, right? So this PDF will be there for you. So all these equations, all these general conclusions, you will get it in the PDF. You just have to right now focus on the problem solving that we are going to start. Okay, but the PDF will be password protected and I'll tell you password somewhere in between. Okay. If two pairs of irrational roots are equal, so again e power alpha x, c1 plus c2x cos hyperbolic root beta x, c3 plus c4x sin hyperbolic root beta x. Okay, last two cases and then we take up the questions. If a pair of roots is imaginary, complex conjugate actually, not pure imaginary. If a pair of roots is complex conjugate, that is of the form alpha plus minus I beta. Alpha plus I beta, alpha minus I beta. Then your complementary function will be e power alpha x c1 cos beta x. In case of irrational, you get the cos hyperbolic. Here it is the c1 cos beta x plus c2 sin beta x. And again, if two pairs of complex conjugate roots be equal, then you have e power alpha x, c1 plus c2x cos beta x, c3 plus c4x sin beta x. Understand with the help of questions. Find the general solution of d2y by dx square plus 2dy by dx plus y equal to 0. Now, automatically, right, in the Telegram group, it will be there in the Telegram group. Okay. And this one you will get today only after session. Ye mil jayega aapko today. Okay. And you will also get the yesterday's solution, but uske liye you'll have to wait. But this already handwritten. This is already we are writing, so this you will get immediately. Now, whenever the gx is equal to 0, see, in general, the general solution is complementary function plus pi, cf plus pi. Pi depends on the gx. Okay, but right now we are not talking about gx. Okay, so only cf. For CF, you need auxiliary equation, right? Now, no, don't do the formality of writing d square plus 2d plus something. I will directly write down the auxiliary equation. Of course, there will be d square and something. But for auxiliary equation, you convert the d to m. So second derivative will be m square plus twice of first derivative. First derivative is m plus constant 1. Directly can I write like this? Na? No need to write down d square and those terms. Okay, directly write down the auxiliary equation. And here, this is nothing but m plus 1 whole square identity. So what is the value of m? Minus 1, minus 1. Which case? M is minus 1, minus 1. Which case? Real and equal. So what is the complementary function? The complementary function is c1 plus c2x, right? c1 plus c2x e power mx, e power minus x, and that itself is the general solution. If there is pi, the general solution will be cf plus pi, but here it is only equal to the cf. The answer is c1 plus c2x e power minus x. Similarly, next question. Find the solution of d2y by dx square equal to 0. d2y by dx square equal to 0. What is my auxiliary equation? My auxiliary equation is m square equal to 0. Right? M square is equal to 0. So m is equal to 0 and 0. M is 0 and 0. Okay. Again, real and equal case. Right. So if this is again real and equal, so what will be the complementary function? That will be the general solution also. c1 plus c2x e power mx. M to 0 hai, right? So e power 0 is 1. So answer is simply c1 plus c2x. Now this can be solved directly also. This is also an alternate method. Okay. d2y by dx square is differentiation of first derivative. right? So when I integrate on both the sides, na, okay, when I integrate, one of the derivative is cancelled. I am left with the first derivative, and integral on the right hand side, suppose that is equal to some constant, that is C2. Okay, now integrate once again. Integrate once again. So y will be integral of C2. Integral of C2. C2 dx will be C2x plus some more constant C1. That is how you can write down. So this one you can do directly also, but not all such. So CF is the method for the LCCDE. d2y by dx square minus 2dy by dx minus y equal to 0. Chandrasekhar, it all depends on the temperament of the students till the end of the session. Anyways, I have found low attendance today, so I'll take a call on that, not maybe immediately. Find the general solution of d2y by dx square minus 2dy by dx minus y equal to 0. Very quickly, auxiliary equation. M square minus 2m minus 1 equal to 0. The m will be equal to, let's solve this quadratic equation, minus b plus minus root over b square minus 4ac. So minus minus plus ho jayega, divided by 2a. So what is the value of m? 2 plus minus root 8. Root 8 is equal to 2 root 2. Divide by 2. So 2 and 2 cancel. 1 plus minus root 2. What is the type of equation? No, answer is not 0, Satya. Why the answer will be 0? Is C1 plus C2x. Tell me guys, m is 1 plus minus root 2. M is known as the 1 plus minus root 2. What is the type of case coming up here? Dekho, there are two ways of solving it. M is 1 plus minus root 2. Or that is alpha plus minus root beta. Irrational pair. So one of the case is irrational pair. So the complementary function will be e raised to the power alpha x C1 cos hyperbolic root beta x, root beta is root 2, plus C2 sin hyperbolic root 2x e power x C1 cos hyperbolic root 2x plus C2 sin hyperbolic root 2x. That should be the answer. That should be the answer. Next. Na, complex conjugate nahi hai. Smart and Manas, this is not complex conjugate. Complex number kab aayega? When you have under root of negative number, that will give imaginary iota. Okay. Or, now this is one way. Or, now what is the correct option? That depends on the option. What is the type of option given? Do possibility hai yahan pe. M is 1 plus minus root 2. That is eventually 1 plus root 2. 1 minus root 2. What does it mean? 1 plus root 2, 1 minus root 2. They are again real. It's not imaginary, it's not complex. Okay, it's not imaginary, it's not complex. So they are both real as well as distinct. One is 1 plus root 2, one is 1 minus root 2. Right? So if they are real and distinct, the complementary function can also be written as C1 e raised to the power m1x plus C2 e raised to the power m2x. C1 e power m1x plus C2 e power m2x. This is also a possibility. Now, if you expand sine and cos hyperbolic, if you expand sine hyperbolic, cos hyperbolic by the Euler's identity, these two answers are relatable to each other. Okay. So that's not a big worry. The point here is that depending on the option, so you look into the option. If the options are in the form of hyperbolic function, apply the irrational pair formula. If the option doesn't contain hyperbolic, if it contains only exponential type of option, then take the real and distinct. So alpha plus minus root beta can be solved by two ways. Depending on the option, you will decide in the exam. Right? Next next question. d2y by dx square plus 2dy by dx plus 2 equal to 0. Very quickly. This should be solved just very quickly. So what is the auxiliary equation? M square plus 2m plus 2 equal to 0. M square plus 2m plus 2 equal to 0. Right? Now, this time m is minus 2 plus minus root over b square, that is 4, minus 4ac, so 4 2s are 8, divided by 2a. So m is minus 2 plus minus under root of minus 4. Under root of minus 4. Under root of minus 4 is the imaginary number, that is 2i. Okay, divide by 2. So here m is minus 1 plus minus I. Got this? This is where iota is coming. You were confusing in the previous question. Okay, so what is the m is minus 1 plus minus I, and this is like alpha plus minus I beta. So the general solution of the problem is yc, and that is equal to e raised to the power alpha x. E raised to the power alpha x formula already I told you. It's e raised to the power alpha x c1 cos beta x. Beta का value भी 1 है, तो c1 cos x plus c2 sin x. c1 cos x plus c2 sin x. That's it. E power minus x c1 cos x plus c2 sin x. Okay, done. This problem is done. Next one. Find the general solution of d4y, fourth order differential equation. So you will start with m power 4 plus 2 d2y by dx square, directly second derivative term, so m square plus 4y, right? It cannot be 4. Previous question में देखे ना correct है कि नहीं? Previous question also it has to be 2y. All this is to be corrected. ये correct है. हाँ. So this was typo. This is plus 2y. This has to be plus 4y. So m power 4 plus 2m square plus 4 will be 0. Now, if you observe, this is like m square plus 2, 9. There has to be a correction in the question. Let's make it 4. Madam, this is also a valid question, but what is the type of case I want to discuss? उसके according यहाँ पे इसको हम 4 कर देते हैं. So let's do a small correction. So it is 4m square plus 4 equal to 0. The type of case which I wanted to discuss here, so that all cases of CF are covered, and this becomes again the identity m square plus 2 whole square equal to 0. A square plus b square plus 2ab. A square plus b square plus 2ab identity है. ठीक है. Now what should be the value of m square? m square plus 2 का whole square, repeated factor है, तो m square is minus 2 repeated. M square is minus 2. I want m. Sir, what is the under root of minus 2? Under root of minus 2. Under root of negative number. Right. First of all, under root means plus minus will come. Under root of negative is iota root 2. Again plus minus iota root 2. What is this case now coming up? Here m is plus minus I root 2. Plus minus I root 2, that is like alpha plus minus I beta, complex conjugate, but not only one time, same complex conjugate coming twice, right? Alpha plus minus I beta and again alpha plus minus I beta. So what is this case here? The last case which I have told you, repeated complex conjugate. Repeated complex conjugate pair. Repeated complex conjugate pair. So your answer will be e raised to the power alpha x. Alpha का value कितना है? 0. There is no real part. E raised to the power alpha x. C1 plus C2x cos beta x. What is beta? Root 2 plus C3 plus C4x sin root 2x. C1 plus C2x cos root 2x plus C3 plus C4x sin root 2x into e power 0, and eventually e power 0 is 1, so I can remove it. ठीक है? E power 0 को 1 कर दिया. No, hyperbolic is there when you have irrational pair. This is not irrational. It's repeated complex conjugate pair. Okay, Manas? So this is what is the answer. So these questions summarizes all different forms of the CF. All different forms of the CF that we have covered. Let's quickly go through the PI also. So as I told you, the generalized LCCDE, the generalized linear higher order differential equation was FD equal to Y. When you take the GX equal to 0, that is the homogeneous differential equation, and its solution was CF. Right, if Gx is not equal to 0, we also find Pi, and as I already told you, Pi it depends on the gx. It is 1 upon fd gx, but how to further solve depends on the type of function. So like the cases of CF, I will quickly summarize the cases of PI. Okay, and so that you are comfortable with all sorts of problem here. Okay, first case is, suppose if gx is equal to e power ax, if gx is an exponential function, so its pi is simply given by 1 upon fa e power ax by putting d equal to a, right? But it is 1 upon fa e power ax, 1 upon fa e power ax, provided denominator should be non-zero, because if the denominator is 0, it becomes the undefined case, right? If the denominator is 0, if fa is equal to 0, then y is x upon f dash a e power ax, x upon f dash a e power ax, but now the derivative should be non-zero. If the derivative is also 0, then you go for x square upon f double dash a e power ax. That means you keep trying unless and until you get a non-zero denominator. If the first one itself is non-zero, then this is not required. Okay, let's understand with the problem. So here pi case by case problem karte. Now what is the particular integral? I'm not asking CF now, forget, we are done with the CF. You can again find the CF, right? You can again, I'll keep giving you homework. For this, calculate the CF as homework. For this, ultimately it's a differential equation, you can calculate it CF also. You can do that as homework. Right now, let's focus on the PI part, particular integral. But what is the gx function? What is the gx function? इसको थोड़ा सा simplify करेंगे. Gx is minus 2 cos hyperbolic x. What is the cos hyperbolic x identity? Cos hyperbolic identity is e power x plus e power minus x divided by 2. So eventually gx is minus of e power x plus e power minus x. E power x plus e power minus x. E power x plus e power minus x. Done. Now exponential case, actually. Exponential case. Okay. So what is this equation? F of second derivative d square y plus 4 first derivative dy plus 5y is gx, right? So d square plus 4d plus 5 whole multiplied by y is gx, and that is what is fd into y is gx. fd into y is gx. Okay. What is the pi? What is the pi? Now यहाँ पे दो पार्ट में ब्रेक करेंगे हम. See, f of d into y, f of d into y, f of d का वैल्यू रख लेते हैं. So we have d square plus 4d plus 5 into y is equal to gx, and gx is minus of e power x minus e power minus x. दोनों लिख लेते हैं यहाँ पे. ठीक है जी. Minus of e power x minus of e power minus x, right? Let's think with respect to minus e power x first of all. What is the pi corresponding to this? It is 1 upon, now minus of e power x, a का वैल्यू 1 है, a is equal to 1, e power ax में a is equal to 1, तो pi will be 1 upon f of 1, 1 upon f of 1 into gx. ठीक है, into gx. Gx is e power minus e power x. First only minus e power x I am taking. What is the f of 1 then? What is the f of 1? fd में d की जगह 1 रखेंगे, तो 1 upon 1 plus 4 plus 5. 1 upon 1 plus 4 plus 5. Okay, into minus of e power x. So this is total 10. So this answer is minus e power x divided by the 10. Okay, next, if I take the minus e power minus x, so here a is equal to minus 1. A is the coefficient of x in the exponent in the power. What will be the pi? 1 upon fa. 1 upon fa. A की जगह आएगा minus 1. 1 upon fa into gx into minus e power minus x. That is 1 upon a की जगह minus 1 रखा, तो 1 minus 4 plus 5. 1 minus 4 plus 5. This becomes 6 minus 2, and that is equal to 2. 6 minus 4, that is 2. So minus e power minus x is divided by the 2. Minus e power minus x is divided by the 2. Correct? A is divided by the 2. So what should be the PI? What should be the total PI? Okay, what should be the PI? The PI of the problem is then given by, okay, adding both the parts, minus of e power x by 10 minus of e power minus x by 2. That is the answer. Any doubts, please ask me. Any doubts, please ask me. Next question aayega. What is the PI of d square plus 2d plus 1 into y equal to e power minus x? Again, the complementary function will be a homework to you. Okay. Complementary function, because we have discussed all cases, so that you can try as a homework again. Try as a homework again. And one more thing before we solve this question. The password for today's PDF. Yeah, we have a few more cases going ahead, but just I thought at random in between, let me give you the password, and password is CFPI. That is what we are discussing right now. Everything in small without any spaces. CFPI. The password of today's PDF is CFPI. Okay, chalo. Now, this is again of the form fd into y is e power minus x. Okay, what is the fd? D square plus 2d plus 1. And what is the value of a? E power ax. What is the a? Is minus 1. What is the f minus 1? What is the f minus 1? F minus 1 will be 1 minus 2 plus 1. That is 0. So I told you whenever fa is equal to 0, you can't use the first form of pi. So you have to differentiate this function. So what is the derivative? F dash d. 2d plus 2. 2d plus 2. Now what is f dash minus 1? Minus 2 plus 2. Sir, ye bhi 0 aa gaya. Do till you get non-zero denominator. So next will be f double dash d. F double dash d is equal to 2. 2d ka derivative 2 plus 2. Differentiation of constant is 0. Here you get 2. F double dash d is 2. That means f double dash a. Actually, I want a. Okay, f double dash minus 1. But since f double dash d is 2 constant, so f double dash minus 1 is also 2. That is constant. And eventually it is non-zero. So here you get the non-zero form. Right. So what should be the pi? Again, the question is only on pi. So what should be the pi here? Guys, as I told you, for second derivative form, there will be x square in the numerator. X square 1 upon f double dash minus a. That f double dash minus 1 into e raised to the power minus x. Correct. So this is equal to x square divided by 2. X square divided by 2 e power minus x. That is the answer. This is the pi. Done. All of these are important cases. Okay. Now the next case of the function gx. Okay. If suppose the gx is constant. Isko very quickly I'll tell you. If the gx is constant, there's nothing great here. Dekho, if gx is constant, so constant can be written as k e power 0x. K e power 0x. Right. So this is the form k e raised to the power ax with a equal to 0. So you can solve it using the previous case only. Whenever the right hand side gx is just constant, you can solve like the case number 1 with a equal to 0. That means the pi is 1 upon fa. 1 upon fa na? So 1 upon f0 k e power 0x into gx. E power 0 is 1. So k upon f naught. Right. So the simple solution pi is k upon f naught. But once again, denominator should be non-zero. Right. In case denominator was 0, then what will be the pi? We know x upon f dash 0 into k. Right. Into k. That means it is kx upon f dash 0, but this is applicable if f dash 0 is not equal to 0. If the f dash 0 is not equal to 0, okay? If the f dash 0 is also equal to 0, you know what to do next. Same, because it's the case number 1 repetition with a equal to 0. Okay, so you can get the question on constant also on the right hand side. Next important case, if the gx function is the sinusoidal function, sin ax plus b or cos ax plus b. Yeah, next important case hai. Sin ax plus b or cos ax plus b, and in this we know that pi is 1 upon fd into gx. For the exponential function, substitution is d equal to a. For the exponential, we have put d equal to a 1 upon fa into gx. Here, put down d square equal to minus a square. Right? So, I can write down like this. Here, the pi is 1 upon fd, but there is no substitution of d. There is the substitution of d square. So, 1 upon fd with d square equal to minus a square into the gx. But provided denominator is non-zero. Provided the denominator after this substitution is non-zero. If it is 0, what to do? If it is 0, what to do? If fd after the substitution is 0, then what will be your pi? Then it is again x multiplied in the numerator. Same thing. X multiplied in the numerator, 1 upon f dash d, and again in the f dash you will have the same substitution. This should be your answer, x into 1 upon f dash d into gx. Okay, so let's understand with the question. Okay, find the pi of, find the pi. Only we are focusing on pi. CF we have already discussed. So d square plus 3d plus 2 into y is equal to sine 2x. d square plus 3d plus 2 into y is equal to the sine 2x. Okay, d square plus 3d plus 2 into y is equal to the sine 2x. Correct? Okay, so let's write down. Okay, let's write down कि we have sine 2x and a is equal to 2. Okay, what is the fd? Okay, d square plus 3d plus 2, and you will have to put d square equal to minus a square. That will be minus 4, right? So then, after the substitution, fd will become minus 4. Guys, there is no substitution for d. Dhyan rakhna. There is only d square, but there is no d substitution. So this is going to be left in the form of d. This is 3d minus 2. This is 3d minus 2. So what is pi now? Pi is given by 1 upon fd. It is given by 1 upon fd after substituting d square equal to minus a square of gx. So place down the value, dear. After the substitution, you have got the fd is equal to 3d minus 2. So 1 upon 3d minus 2 into gx. The gx means the sine 2x function. Now how to go forward? You don't have any substitution of d. You don't have any substitution of d. So what to do? In that case, you will multiply and divide by 3d minus 2. You will rationalize this so that again you get d square in the denominator. Multiply and divide by 3d plus 2. It is a minus b, multiply divide by a plus b. Okay. So that will become how much? It is 3d plus 2 divided by a minus b, a plus b will be 9, a square minus b square. So 9d square minus 4 into sine 2x. Into sine 2x. Now, once again, you will have d square equal to minus 4 applicable. But still there is a d left in the numerator. उसका भी क्या करेंगे देखेंगे. 9 minus 4 minus 36 minus 4 minus 40. There is still a d in the numerator left. What to do with the d in the numerator? D in the numerator is simple to deal, but a single d in the denominator will make the complications. Okay, now how to deal with the d in the numerator? So देखो, minus 1 by 40 is constant. बाहर लिखेंगे इसको. This is 3d sine 2x plus 2 sine 2x. 3d sine 2x plus 2 sine 2x. Done है जी? D sine 2x plus 2 sine 2x. Now, what is the meaning of this, everybody? What is the meaning of this? Numerator mein d is not a problem. Why? Because d of some function, d is a differential operator. D of some function is like differentiating the function. D is a differential operator. This is d by dx of sine 2x, and the differentiation of sine 2x, so we know na 2 cos 2x. 2 cos 2x. But yeah, correct, Dilip and Tarun. Very good. Okay, so eventually your answer yp is minus 1 by 40. 3 2 हो जाएगा 6 cos 2x plus 2 sin 2x. That's your answer. Done है जी? Done. Again, you can take a 2 common and divide. That's okay. That's absolutely okay. Let us stop here. 1 by 40, not 44. 9 into 4, 36, and then 4. So 40 it is. Swapnil. What is the particular integral pi again of the differential equation? See, again, we are right now focusing only on the pi part. So what is that? D cube y by dx cube. D cube y by dx cube. That is the third derivative. So d cube will come. D cube of y plus 4 first derivative of y, 4 dy is equal to sine 2x, right? D cube plus 4d into y is sine 2x. Right? Now in this sine 2x, the value of a is equal to 2. Again sine 2x में a का value 2 है. But what is the fd function dear? fd is d cube plus 4d, and in this I can take the d common first of all, so I am left with d square plus 4. अब यहाँ पे देखो क्या होगा. Okay, so I have the fd which is d into d square plus 4, and number one substitution is putting down d square equal to minus a square. A का value तो 2 है, so this is minus 4, and after putting this, what is the value of fd is going to be 0. d square is minus 4, तो minus 4 plus 4 cancels, that is equal to 0. तो fd तो 0 हो गया सर. अब अगर fd 0 है तो क्या करेंगे? We will have to differentiate this. Right. We have fd, again opening up d cube plus 4d. I will differentiate this fd. So I differentiate, I get 3d square plus 4. Correct? Perfect. Now once again d square equal to minus 4. Once again I do the substitution, and this time I get 3 into minus 4 plus 4. Okay, that is minus 8. Minus 12 plus 4. This time it is minus 8. This is known as the minus 8. This is known as the minus 8. Acha, if this is known as minus 8, what should be the pi? Okay, if this is minus 8, what should be the pi? Which form are you going to use? The first derivative form. fd was 0, so f dash d, first derivative form, and in the first derivative there has to be a x in the numerator, x into 1 upon f dash d into gx. That is the form we are going to use. So this is x into 1 upon f dash d, which is simply minus 8, into the gx, which was sine 2x. So your answer is minus x sine 2x divided by 8. Your answer is minus x sine 2x is divided by 8. Minus of x sine 2x is divided by 8. Okay, done. Next case, when the next case number 4, when gx is an algebraic function. When the gx is an algebraic function in the power of x, okay, polynomial type of function. Say for example, okay, x power 4 plus 2x plus 1. Okay, fourth order polynomial function. This is an algebraic function here. Find the pi of the differential equation y triple dash. Now what is the method here? I'll tell you with the question only. That is why this slide is empty. Let's take the method with the question. X power 4 plus 2x plus 1. अब देखो. What is this? Third derivative again. That is d cube plus 8. Y को common ले लिया is equal to gx. So dear, what is one of the way of writing the pi? We know that pi is written as 1 upon fd into gx. Understand the method directly here. What is the pi? That is known as 1 upon fd. 1 upon fd, that is 1 upon d cube plus 8 of gx. Of the gx. And gx का value अगर लिख दें तो x power 4 plus of 2x plus 1. Okay. Now the first step is 1 upon fd. Denominator bring to the numerator first of all. Yeah, one more thing you can do first of all. Take the 8 common. Let the denominator be 1 plus something. Let the denominator, listen to the method here. Let the denominator be 1 plus something. तो 8 को common लिया तो 1 plus d cube by 8. So let that constant be 1. Okay. Now shift it to the numerator. Now shift this to the numerator. So you have 1 plus d cube by 8 का whole inverse. 1 plus d cube by 8 का whole inverse into x power 4 plus 2x plus 1. Now here you will have to use the series. Here you will use the series, right? What series you will use? 1 plus x whole inverse. Yes. So this is derived, either by Taylor series, either by geometric methods, or either by the binomial expansions, binomial theorem. So 1 plus x whole inverse is 1 minus x plus x square minus x cube plus x power 4, alternate plus minus. Suppose in some question it may be 1 minus x whole inverse, ये भी पता होना चाहिए. It may be 1 minus x whole inverse. So that is given by all positive powers. 1 plus x square plus x cube. All positive coefficients, I mean. 1 plus x square plus x cube, etc., etc., etc. ये हो गया 1 minus x whole inverse. So let's use this in the PI. So we have the yp as 1 by 8, 1 plus d cube by 8, whole inverse. Okay, using the expansion 1 plus x whole inverse, so we have 1 minus x plus x square. So x square कितना होगा? d power 6 upon 64 minus x cube. So d power 3 का cube will be d power 9. 8 cube is 5 and 12, etc., etc., etc. Now to be applied to x power 4 plus 2x plus 1. So sir, this series goes to infinity. This series runs for infinite number of terms. So what case to be taken? How many terms to be taken? How many terms to be taken? तो यहाँ पे आप note करेंगे that it's a fourth order polynomial. It's a fourth order polynomial. You can only calculate up to the fourth derivative. You can only calculate up to the fourth derivative. देख लीजिए ना. What is the gx? Right. What is the first derivative of it? 4x cube plus 2. What is the second derivative of it? 4 3s are 12x square. What is the third derivative of this? That is 12 2s are 24x. What is the fourth derivative of this? That is equal to 24. What is the fifth derivative of it? That is equal to 0, because it's a constant and derivative will be 0. Will be 0, right? So the point here is ki how many terms to take? That is equal to the degree of the polynomial function gx, right? And the degree here is 4. So you have to consider only up to the 4 terms here, up to the 4th order. Number of terms means up to the degree of gx. It's the number of terms 4 nahi hai. The number of terms is up to the degree of gx, and that is 4. So up to the 4th order. Don't take these 4 terms. Up to the d power 4, right? This here means up to the d power 4. Okay, but d power 4 to hai nahi. That means up to the d cube, right? So your pi will be 1 by 8, 1 minus d cube by 8 of the gx. Okay, so that is 1 by 8. Bring the gx inside, that is x power 4 plus 2x plus 1 minus 1 by 8 of the d cube. We have the d cube already. Let's copy this here. D cube matlab 24x. The third d cube matlab the third derivative, that is 24x. Okay. So हो गया 1 by 8 of x power 4 plus 2x plus 1 minus 3x. So your eventual final answer is 1 by 8 x power 4 minus x plus 1. 1 by 8 x power 4 minus x plus 1. X power 4 minus x plus 1. Answer is C. Yes, Manas. So up to the 4th degree, whether it is 2 terms or 3 terms, usko yaad mat rakho. If it is the 4th degree polynomial, up to the d power 4 term. Up to what? Up to the d power 4. That is important. That is important. Okay. Okay. Now the next case, first 4 cases are important for PI. Okay, but there are, some combination cases as well. If exponential multiplied by some function phi x, okay, that phi x could be algebraic function or sinusoidal function, any other thing. Okay, then the PI is given by e power ax 1 upon fd plus a into phi x. E power ax into 1 upon fd plus a into phi x. Let's understand this again with the help of question. Okay, what is this function here? See, what is the gx is x square e power minus x, or I can write this as e power minus x into x square. This is known as the function phi x. This is known as the function phi x, right? Okay, so let's write down this differential equation properly. Second derivative, sir, d square plus 2d plus 1 whole multiplied by y is e power minus x into x square. Okay, this is again fd into y is gx, right, where gx is e power minus x into x square. Acha, e power ax, we need to place 1 upon f पर d plus a. So what is a? It is in the exponential power. तो यहाँ से आप बोल सकते हो what is the a? A is minus 1 here. Coefficient of x in the exponential power. So the pi is given by the formula e raised to the power ax 1 upon f of d plus a into the phi x. That is the method. Okay. So यहाँ पे अगर हम put करेंगे value को, so it is e raised to the power minus x, a minus 1 है, 1 upon f of d minus 1 into the phi x. What is the phi x function? Is x square. X square is algebraic. क्या करना है आगे देखेंगे, but first let's talk about fd minus 1. What is fd? Dear, have a look. Fd is d square plus 2d plus 1, and that is actually d plus 1 whole square. That is actually d plus 1 whole square. Done, hai ji? So fd is actually d plus 1 whole square, right? So what should be f of d minus 1? Replace d by d minus 1. Replace the d by d minus 1. So d minus 1 plus 1, 1 cancel. So it is simply d square. It is simply d square. So what's going to be your pi then? Your pi is e power minus x into 1 upon fd minus 1. That is simply 1 upon d square of x square. Now, although it's algebraic case, but we don't need to use the series here. 1 plus x nahi ban raha hai. It cannot be solved with the series 1 plus x whole inverse like the previous question. But it is 1 upon d square. And what is the meaning of 1 upon d square? What is d? 1 upon d square को split कर देंगे. What is d is differentiation. So 1 upon d inverse of differentiation is integration. It is integration. So this is equal to e power minus x 1 upon d integral of x square is x cube by 3. Right. One more time integration will come. E power minus x. So one more time integration will come to x power 3 ka integral is x power 4 divide by 4 and 4 3s are 12. So your answer is e power minus x, x power 4 by 12. Done. Done. Done, 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 done. So d is known as the differentiation with x. So 1 upon d is the inverse of it, and that is known as the integral. Right? That is known as the integral of the function with dx. Integral of the function with dx. Done. So 1 upon d square means repeated integration. Okay, first 1 upon d and then again 1 upon d. Okay, the repeated integration will come up here. And the next case of pi is x into phi x. Next combination is algebraic term, that is x power 1 into phi x. It's pi. Always pi is 1 upon fd into gx. But after simplifying for this gx, you get x minus f dash upon f into 1 upon f of phi x. Phi x kya hai? Let's see an example. It could be here, any other function like exponential or sinusoidal or anything. Okay, the most common question here can be x into sin x type of question. So x minus f dash upon f into 1 upon f into phi x. D square plus 4 into y is x sin x, right? It is x sin x. This is the phi x now. This is the phi x. And what is the f dash? Yeah, what is the fd? D square plus 4. So what is going to be the f dash d? That is 2d, because here I need the f dash d also. Here I need the f dash d also. So let me write down the pi here. Everybody, it is given by x minus f dash divided by f is whole multiplied by 1 by f into the function phi x. That is the form to be used. Place down the values. So this becomes x minus f dash, right? F dash, that is 2d upon d square plus 4 into 1 upon d square plus 4 applied on phi x, and phi x here is sin x. Now guys, what is the function actually left is sin x, and what is the method for sin x? What is the method for sin x? What is the method for sin x? Tell me. The sin x method is d square equal to minus a square. The sin x method, case number 3 already we have discussed. Put d square equal to minus a square, right? A equal to 1 here, right? That is minus 1. So put down the d square equal to minus 1, but there is no substitution of d, right? So जब इतना करेंगे, what should be the yp then? Yp is x minus 2d upon d square plus 4, right? D square is minus 1. So upon minus 1 plus 4 whole multiplied by 1 upon minus 1 plus 4 into sin x, right? So this is x minus 2 by 3 into d into 1 by 3 sin x, multiply inside. So 1 by 3 x sin x, this is done, minus 2 by 3 into 1 by 3, 2 by 9 into d of sin x. What is the meaning of d of sin x? D of sin x is differentiation of sin x, and that is going to be cos x, right? And this is what is the yp. 1 by 3 x sin x minus 2 by 9 cos x. 1 by 3 x sin x minus 2 by 9 cos x. Hi, good afternoon, Bhanu. I'm good. How are you? This is the answer. 1 by 3 x sin x minus 2 by 9 cos x. This is the next case, comprising of x into sin x or x into phi x case. X into phi x case, right? Then let me also take you towards one more important case here, that is the Euler-Cauchy homogeneous linear differential equation. Okay, what is the Euler-Cauchy pattern? That every derivative of nth order will be multiplied by x power n. Every derivative of nth order will be multiplied by x power n. Say for example, you may have x square d2y by dx square. So if it is second derivative, it is multiplied by x square, right? Plus 5x dy by dx. So if it is the first order, it is multiplied by x power 1, right? Plus 6y is equal to gx. Okay. Now, is this linear? Is this directly a linear differential equation? Arey, homogeneous linear kaise likh diya? Sorry. That's a typo error. This is not linear, okay? I think I was thinking about something else. I think. My question was actually something else. That is linear only. Okay, that is linear only because the dependent variable y and all the derivatives are in first degree and they are not multiplied together. My question was, is it LCC DE? This is linear, I agree. Sorry, my question was something else. It is a slip of tongues. It is linear because the dependent variable and all the derivatives are in first degree. They are in the first degree and they are not multiplied together. That is what linearity means. So this one is linear. Agreed. Right. But does it have constant coefficient? Okay, this one is constant, but what is the coefficient of first derivative? It is 5x. It's a function of x. What is the coefficient of second derivative? It is x square. It's a function of x. So the derivatives are not, the coefficients are not constant, right? The coefficients are not constant. Okay, so it is linear, but it is not LCCDE. It is not LCCDE, but it is an equation convertible to LCCDE. It is an equation convertible to LCCDE. How? The method is one substitution. Put x is equal to e power t. Acha. If you put x equal to t, what is going to happen? If x is equal to t, of course t is log x. If x is t, t is log x, right? So x का substitution तो बता दिया, right? But we also need to think about dy by dx. We also need to think about the dy by dx types of term. I can break this. Dy by dx is dy by dt multiplied by dt by dx. Let's apply the chain rule here. So it is dy by dt into dt by dx, right? What is going to be dt by dx? T is log x. So differentiation of t with x is 1 by x. Now shift the x on the left hand side. So x dy by dx is dy by dt of t. So that means here I will call the d operator, dhyan dena, here I will call the d operator as the differentiation with t. Okay, let d by dt equal to the differential operator. What is the capital D? We all know is the differential operator. Differentiation with whom? You can specify. So I am specifying it's the differentiation with t here. Okay, so I again repeat, if x is e power t, you are getting an important result that x dy by dx, x dy by dx is equal to dy by dt, but d by dt is the differential operator, so that is dy, that is capital dy, right? Similarly, let's not derive again. Second step में क्या मिलेगा ना, if you differentiate this again, you will get x square d2y by dx square. You will get that as d minus 1 into y. You will get this as d minus 1 into y. ठीक है? X square d2y by dx square will be d minus 1y. Right? So you will get the substitution of x dy by dx, x square d2y by dx square. Okay? Similarly, suppose if it is third derivative. Suppose, वैसे third derivative तक आएगा नहीं, but suppose if it is third derivative, x cube d cube y by dx cube is equal to d minus 1 d minus 2 whole multiplied by y. So it keeps on moving forward. So if I apply this on the question now, find the solution. X square d2y by dx square, ये क्या है? X square y double dash, x square d2y by dx square plus x dy by dx minus y is equal to 0. Right hand side there is no forcing function, is equal to 0. ठीक है? Now if that is the case, I will, this is the Euler-Cauchy equation. So substitution we all know the substitution. So x will be named as e power t. If the x is e power t, so we know x dy by dx will be d of y. But what is this d? It is the differentiation with t. And x square d2y by dx square will become d minus 1y. So once I substitute these values, x square d2y by dx square is d minus 1 into y, right? Plus x dy by dx, that is dy minus y is 0. Guys, d square minus d plus d minus 1 whole multiplied by y is 0. Now eventually you must be feeling that all the coefficients of the differential term are constant. सब कुछ constant हो गया. This is going to be cancelled, no doubt, but eventually this is becoming constant coefficient. Right? This is d square minus 1 into y equal to 0. Or I can say that we have got d square minus 1 into y equal to 0, or I can say that we have obtained now f of d into y is equal to g of x, which represents the LCCDE, right? So you have eventually obtained the LCCDE. So this is the equation which is convertible to LCCDE. Let me again tell you that this is linear, this is not LCCDE, but it is convertible. It is convertible to LCCDE by a substitution method. Okay, and once it is converted to LCCDE, what is the method? Once it is converted to LCCDE, what is the method? You will start solving the CF and PI. You will start solving the CF and PI. That is the method. You will start solving the CF and PI. That is the method. Okay, so equation है आपके पास d square minus 1 into y is 0. Sir, gx is equal to 0. So there is no PI. There is no PI. Sorted hai. There is no PI. Only CF is required. Right? Only CF. For CF, I need the auxiliary equation. Auxiliary equation d की जगह m रखेंगे तो m square minus 1 is 0. तो m is equal to plus or minus 1. Under root of 1 is plus or minus 1. Right? So m is equal to 1 minus 1. What is the case here, sir? Already studied real and different, real and distinct. Right? So what is the YC? What is the complementary function? Now one precaution. One precaution. What is the complementary function? C1 e power m1x plus C2 e power m2x. ये लिख दिया मैंने. C1 e power m1x plus C2 e power m2x, and I will write down one more thing here. And this is wrong. Yeah, that is the precaution. Sometimes you can commit the mistake here. ध्यान रखना here. Already I told you what is this d. D is differentiation with time, differentiation with t. Here it is a function of t. Y is a function of t. Y was a function of x, but x is converted to t. So y is a function of t actually, right? So what should be the correct answer then? Right? YC is C1 e power t plus C2 e power minus t. X की जगह t लिखना है, सिर्फ इतना रखना है, right? If you choose this, then this is a tick mark. ये correct है, boss. This is correct. But the question was not in terms of t. Question was not in terms of t. तो question को फिर से simplify कर लेंगे. We have the YC is C1 e power t plus C2 e power minus t. Okay, e power t is known as the x. So what is the YC? It is C1x plus C2 e power minus t is 1 upon e power t. So that is 1 upon x. X inverse actually. That is x inverse. So ये आ गया. अच्छा, what is the total solution actually? YC plus YP, but YP वाला part to 0 है. That means the total solution of the problem is also C1x plus C2 divided by the x. This is the answer for the question. This is the answer in terms of expression. Okay, but they have given some initial value so that we can solve. The boundary and initial values are given. Y0 is 0, Y1 is 1. We can find C1 and C2. ये लीजिए, वो भी कर लेते हैं. Right? Y0 equal to 0. So 0 is equal to C1 into 0 plus C2 divided by 0. But if C2 is divided by 0, 1 upon 0 is infinity. 1 upon 0 infinity. Then 0 and infinity cannot match, na? So only possibility to avoid this is make the C2 0. C2 को कर दिया absent. So what is Y now? Y is C1x. C2 को किया 0. Y is C1x. Now put down Y1 equal to 1. So 1 is equal to C1 into 1. तो यहाँ से C1 आ गया 1. So your final answer. Your final answer. Y is equal to C1x. C1 is also 1. So your answer is y equal to x. The solution of this differential equation is y equal to x. This is expected. This Euler-Cauchy is an expected category in the GATE exam. Okay. Right. Y is equal to the x. So with this, I leave you one similar problem as homework and see straightforward, very similar question. X square d2y by dx square minus 3x dy by dx plus 3y is 0. Again, 0. So pi nahi hoga, only CF. But it is the Euler-Cauchy case. It is not directly LCCDE. And again, some values are given to find C1, C2. Y1 is 1, Y2 is 14. Find the value of Y1.5. They have made it to a NAT question. Okay, a homework. And not only this, these questions are there in GATE for 2 marks several times. Similar questions have been there in GATE for 2 marks for several times. Okay, that's it. We'll stop with all important cases, because I thought of covering little bit more, but looking into the response, I felt throughout the session that attendance is not that promising as it should be expected. Maybe differential equations is easy, you might have studied, that's your call, but still somebody attended the session. I can promise that 99% of the questions of differential equation are from these topic only, because I have covered variable, separable, ordinary differential equation. Partial, I told you I'll bring a separate session on partial, but from ordinary I have covered variable, separable, linear order of first order linear differential equation, higher order linear differential equation, Euler-Cauchy case, right? Yeah, it is important, Cauchy wala. Okay, so almost important. These are the things that I've highlighted in the beginning of the session also, what is more important. So at least all those things are covered. At least, your majority jahan se question aata hai, that is covered. For partial, I think a separate session is more beneficial rather than mixing here. So partial, in the beginning only I told you, partial will plan separate. Ordinary will focus in this session. And ordinary, we have covered the important things. What is not covered, I'll tell you. Some more problems you can practice, of course. Homogeneous you can study separately if you want, if you feel time. Exact differential equation, and after Euler-Cauchy we have one more case, Legendre. Very similar approach. If you want, you can go for that, right? Chalo guys, bye bye, stay safe, take care of yourself.